Hello students, this is Dr. Anita Raj welcoming you for an important session in alcohols, phenols and ethers. In this session, we shall see the general classification of alcohols with suitable examples. Okay students, let's see the classification of alcohols now. See, the alcohols are classified based on two important factors. The first one is based on the number of OH groups present in the alcohols and based on the hybridization of the carbon OH group. Okay, based on the hybridization of this carbon to which the OH group is attached. Okay. So based on these two important criteria, alcohols are classified. Okay. Now let us see how these alcohols are classified based on the number of OH groups. Okay. So based on OH groups, there are four categories. The first one is monohydric, second one is dihydric, then next one is trihydric, and the next one is polyhydric. Okay. And based on the hybridization of the carbon present in the alcohol to which the OH group is attached, there are two types. The one is the sp3 type and another one is sp2 type. Okay. So now let us see one by one with suitable examples, right? So based on the OH group, the first one is the primary alcohol. So okay, see, and that also it's coming under the monohydric type. Okay, as I told you earlier, it is coming, there are different categories, that is monohydric, dihydric, trihydric and polyhydric type. Okay, monohydric. What do you mean by monohydric? Monohydric means that in that particular alcohol only one OH group will be there. Only one OH group. Okay, so that type is called as monohydric alcohol. These compounds contains only one OH group, so those type of alcohols are called as monohydric alcohol. Under monohydric alcohol, we are having primary alcohol, secondary alcohol and tertiary alcohol. Understood? So let us see what is primary alcohol. Actually, in this type, the OH group is attached to the primary carbon. Okay, the OH group is attached to the primary carbon. What do you mean by primary carbon? See, primary carbons are the carbon atoms which will be attached to only one carbon atom. See here, this OH group is attached to one carbon atom. Obviously, this carbon atom is not attached to any other carbon atom. But look at this. So this comes under primary. Okay, primary alcohol. This carbon is primary carbon. And now check the next example, ethyl alcohol. This OH group is attached to this carbon atom and this carbon atom is attached to only one carbon atom. So this carbon atom is a primary carbon, and so this alcohol is a primary alcohol. Understood? Since because the OH group is attached to the primary carbon. Okay, now let us see the next example, that is propyl alcohol. See here, this OH group is attached to one carbon atom and this carbon atom is also attached to only one carbon atom. We cannot consider this one because this is attached to the next one, is it not? But this carbon atom is attached to only one carbon atom, so this one is a primary carbon. So this alcohol is a primary alcohol. So all these alcohols are primary alcohols because the OH group is attached to the primary carbon atoms. Understood, students? What is primary carbon? If the carbon atom is attached to only one carbon atom, then that is called as a primary carbon. Okay. Now next we shall go to the secondary alcohol. In this type, the OH group is attached to the secondary carbon. Okay, so the OH group is attached to the secondary carbon. What do you mean by secondary carbon? Secondary carbon atom means this carbon atom will be attached to two more carbon atoms. Okay, two more carbon atoms. Understood? See here, this OH group is attached to a carbon atom which is again attached to two more carbon atoms. So this is a secondary carbon atom. So this is an example of secondary alcohol, secondary propyl alcohol. Okay, secondary propyl alcohol, or we can give then another name as propan-2-ol. Propan-2-ol. Why 2-ol? Because the OH group is attached to the second position, 1, 2, 3. So 2-ol. See, if you want to know the IUPAC name or common name of alcohols, I have already given it in my another video. I shall give you the link of that particular video in my description box. You can make use of it. Understood? So this is secondary propyl alcohol. Now check this example. See, this OH group is attached to this carbon atom and this carbon atom is attached to two more carbon atoms. This carbon atom is directly attached to two more carbon atoms. So this is a secondary carbon, and since this OH group is attached to the secondary carbon atom, this is an example for secondary alcohol. Understood, students? Now the next one is the tertiary alcohol. In this type, the OH group is attached to the tertiary carbon atom. Okay, so this OH group is attached to the tertiary carbon atom. Tertiary carbon means this carbon atom will be linked to 3 more carbon atoms. Okay, now let us see the example. This is tertiary butyl alcohol. See, this OH group is attached to a carbon atom which is further attached to 3 more carbon atoms. That means this carbon atom is a tertiary carbon atom. So since this OH group is attached to the tertiary carbon atom, this is an example for tertiary alcohol. Okay, tertiary butyl alcohol. Now look at this one. This is 2-methyl-butane 2-all. See, this OH group is attached to a carbon atom which is directly attached to 3 more carbon atoms. Okay, we should not consider this one because this is not directly attached to this carbon. Okay, so this is a tertiary carbon. So this OH group is attached to a tertiary carbon. So it is an example for tertiary alcohol. Then, okay, so we are numbering like this 1, 2, 3, 4. Okay, so this is butane, and in the second position you are having one OH and one methyl group. So we are getting the name 2-methyl-butane 2-all. You can just refer to the IUPAC naming in my video. Okay, so this is an example for tertiary alcohol. Now we are moving to the next category, that is dihydric alcohol. What do you mean dihydric alcohol? See, these type of compounds will be having 2 OH groups. Okay, this will be having 2 OH groups. Understood, students? So now look at this example. CH2, CH2, OH, OH. We are having 2 OH groups. Is it not so? This is an example for dihydric alcohol. Methane, ethane. So ethane 1,2 diol. Okay, ethane 1,2 diol. So another common name is also there. The common name for this compound is ethylene glycol. Okay, ethylene glycol. Okay, ethylene glycol is the common name for this one. And let us see the next example. Here also we are having 2 OH groups, is it not? And this is attached to 2 carbon atoms. Then, and what's the name of this one? Methane, ethane, propane. 3 carbon atoms. So propane, it's the first position 1, second position 2. So propane 1,2-diol. Okay, propane 1,2-diol. So these two are examples for dihydric alcohols. Understood, students? Since because they are having 2 OH groups, right? So the next category is trihydric alcohol. See, in these compounds they contain 3 OH groups. Okay, see, look at this example. 1, 2, 3. 3 OH groups are present. Okay, so methane, ethane, propane, 3 carbon. So propane 1, 2, 3. 1, 2, 3 triol. Okay, propane 1, 2, 3 triol, and that's a common name for this one, and that's nothing but glycerol. Okay, glycerol. Understood, students? And okay, now see the next example. Here in this example also we are having 3 OH groups, is it not? Methane, ethane, propane, butane. So butane 1, 2, 3, 4. So in 3 positions we are having OH groups. So butane 1, 2, 3 triol. Okay, butane 1, 2, 3 triol. So 3 OH groups are there. So this comes under trihydric alcohol. So the last one is polyhydric alcohol. What do you mean by polyhydric alcohol? These compounds will be containing more than 3 OH groups. So if an alcohol is having more than 3 OH groups, then that comes under polyhydric alcohol. Understood, students? Look at this example. How many OH groups are there? 1, 2, 3, 4, 5, 6. So 6 OH groups are there. That's more than 3, right? So this we can say 6 means hexol. Okay. And now look, count the number of carbon atoms here. 1, 2, 3, 4, 5, 6 means hexane. Okay, so 1, 2, 3, 4, 5, 6. In all the 6 carbon atoms, we are having OH group. So hexane 1, 2, 3, 4, 5, 6 hexol. Okay, understood, students? So this is an example for polyhydric alcohol. Understood? Next we shall see how the alcohols are classified based on the hybridization of a carbon atom present in the alcohol. Okay. Now based on hybridization of the carbon atom present in the alcohol, okay, to which the OH group is attached. So before moving into this, you should know what do you mean by sp3 hybridization of carbon, what is sp2 hybridization, and what is sp. Okay, so let me explain here. sp3, listen carefully. sp3 means if a carbon, when a carbon is said to be sp3 hybridized, if a carbon is having 4 sigma bonds, that is single bond, 4 sigma bonds, then it is said to be sp3 hybridized. Okay, a carbon is said to be sp3 hybridized if it contains all 4 single bonds or 4 sigma bonds. Okay, when do you call a carbon as a sp2 carbon? When do we call that as an sp2? See, if a carbon atom is having 3 sigma bonds and 1 pi bond. Okay, that is all three single bond and one double bond if there is, then that carbon is said to be, okay, sp2, okay, sp2 hybridization. Okay, all right students, so based on this category, based on this type of hybridization of the carbon, we are categorizing the alcohols into different types. Okay, so let us see what is allylic alcohol. So allylic alcohol, benzylic alcohol, vinylic alcohol, arylic alcohol and alkyl alcohol all comes under the this classification. Okay, so let us see what is allylic alcohol. See, in this type the OH group is attached to the sp3 carbon next to the carbon-carbon double bond. Okay, see, look at this example. This OH group is attached to a carbon. This carbon is having all single bonds, is it not? See, no double bond is there in this carbon. So, all 4 sigma bonds. So, this carbon is an sp3 hybridized carbon. So, this OH group is attached to a sp3 hybridized carbon and this carbon atom is attached to a double bonded carbon atom. Is it not? This is attached to a double bonded carbon atom. That is, this carbon atom is next to a double bond. Okay. If you are having like this pattern, then that comes under allylic alcohol. We can call that alcohol type as allylic alcohol. See, the OH group is attached to the sp3 carbon atom which is next to the carbon-carbon double bond. Understood? Okay. Now let us move on to the next category, that is benzylic alcohol. See, in this type the OH group is attached to the sp3 carbon next to the aromatic ring. Okay, so this OH, look at this example. This OH group is attached to a sp3 carbon. This carbon is in this carbon all are single bonds. Is not here also single bond, here also everything single bond. If you are splitting this and writing, how will you write? See here, C, here this is attached to a ring, is it not? Alright, and here we have one OH, here H. Alright, understood students? So, all the bonds are sigma bonds, is it not? So, this carbon is a sp3 carbon, this carbon is an sp3 carbon. Okay, in this type the OH group is attached to sp3 carbon atom which is next to the aromatic ring. Understood students? If this is the category, then we can call that as benzylic alcohol. So, this is benzyl alcohol. Understood students? So, next one is alkyl alcohol. What is alkyl alcohol? In this type, the OH group is attached to a saturated aliphatic carbon chain. Understood? See, in this type, the OH group is attached to a saturated aliphatic carbon chain. Mean, see here, okay, see this OH group is attached to a carbon atom which is then again attached to a saturated carbon atom. That is all sigma bonds, sp3, sp3. Okay, if this is the pattern, then we call that alcohol as alkyl alcohol. Understood students? The next one is arylic alcohol. What is arylic alcohol? See, in this type, the OH group is directly attached to a sp2 carbon atom next to an aromatic ring. Okay. See, in this type, the OH group is directly attached to a sp2 carbon atom. See here, this OH group is attached to a carbon atom. See, this carbon atom, here this carbon atom is having a double bond. It's having a pi bond. Is it not? 1, 2, 3, 1, 4. Okay, so 3 sigma bonds and 1 pi bond. Is it not? So that carbon is sp2 hybridized. Okay, and this is present in the aromatic ring. So in this type arylic alcohol, in this type OH group is attached to sp2 carbon next to the aromatic ring. Understood students? Okay, the last one is the vinylic alcohol. See here, in this type the OH group is attached to a carbon-carbon double bond. Mean the OH group is directly attached to a sp2 carbon atom. Direct attachment, this OH group is directly attached to a carbon atom. Understood? Carbon atom which is having a double bond. That means it is sp2 hybridized. Okay. So if this is the pattern, then we call that alcohol as vinylic alcohol. Understood students? Well, fine students, you might have understood what I have taught today. Let me meet you with another important topic in my next video. Until then, it's Dr. Anita Raj signing off from you. Thanks for watching.